Hi guys, I'm Safa.
And I'm Tanu.
So today we'll be explaining about the introduction of Stokes theorem. Let's go. So, Stokes theorem. What we know about Stokes theorem? So to understand this Stokes theorem, we have to learn, or we have to get a recap of what we learned about Green's theorem. So Green's theorem actually relates the surface integral over a plane in two-dimensional space to the line integral of a vector field over the plane's boundary surface, which means that, as we can see from here, it's bounded within a C, which is a bounded region counterclockwise in a piecewise function. But what if this surface has been elevated and it's in three-dimensional? That's where Stokes theorem comes in. So actually, Stokes theorem relates the surface integral over a surface in three-dimensional space to the line integral of a vector field around the boundary of the surface, which means that it is seen in a three-dimensional, as we can see from here. It is moving in a same boundary C, but in an elevated surface. So which means that we have to calculate the same thing, but in a three-dimensional way. That's where Stokes theorem comes in. Okay, and to understand this thing, we can actually use the thumb rule to ensure that we can see the movement of the curl. Okay, and here's the thing: the thumb shows the movement of the direction of the curl itself. I mean, the direction of where the curl is pointing out, and this is the movement of the curl. And if S is oriented surface bounded by simple closed parametric curve C, then the positive direction of C establishes right-hand relationship between the orientation S and C. Okay? Yeah. So, to get a better understanding on how to calculate this thing, will be explained by Tani.
So I'll be continuing from Safa's part, where I'll be talking about how to calculate Stokes theorem. So let's dive into the formula, which previously we have learned about line integral, where line integral formula is basically equals to Stokes theorem formula. As you can see, it is a vector field dot product to the differentiate of R. It is equals to curl of vector field dot product to the unit normal vector ds. So how do you find curl vector field? Is basically your del operator times with vector field dot with unit normal vector and ds. So basically, your surface is in your x and y plane region R. So based on the slide, we can see that like the sentence, it says that surface integral of the curl of a vector field over a surface of S in three-dimensional. As we know, Safa has explained that Stokes theorem talks about the thing in three-dimensional. And I would like to state that if we are not said in the question to use Stokes theorem, we can use line integral to solve the questions. And I also would like to state that previously we have learned about unit vector, and this in Stokes theorem we have learned unit normal vector. They are not the same. They are very different. They are different. Where unit normal vector, if they talks about points perpendicular to the surface, where unit vector is in all direction. Okay, so I would like to conclude the steps on how to solve Stokes theorem. Which the first you have to calculate the curl. Then the next you have to find choose a convenient surface with boundary to C. The third is determine the projection D of S on the x and y plane. And lastly, you have to integrate with the limits. So you have to find the limits also. In some certain questions, you will need to find the limits to integrate, and you will get the answer. That's all.
For the first example, use Stokes theorem to evaluate the line integral of vector f over the surface boundary of C, where C is the circle x squared plus y squared equals to 16, and z is 5, oriented counterclockwise and the vector field of F is this. So I'm gonna use this formula to do the Stokes theorem. For the first step, we do the curl of vector F, which is the cross product of the gradient and the vector F, equals to I, J, K, d dx, d dy, and d dz, yz, 2xz, and exponential of xy. So the unit vector of I, use the AD minus BC, and same as the second unit vector of J and K. So we'll get the answer as x exponential xy minus 2x, y minus y exponential xy, and z. So with step 2, which is this part, which calculate the gradient of z minus f of xy, where f of xy is basically the function of z, which is equals to 5. So the gradient of z minus 5 is equals to 0, 0, 1. So this comes from the d dx of this function to form 0, and d dy, and same as the d dz of the same function. Okay, so now we've done these two parts, so we left with these two parameters. So step 3, where c is equals to x squared plus y squared equals to 16, so r squared is equals to 16, where the radius is equals to 4. So this equation shows a circle. So for a polar form, we should substitute the x equals to r cos delta and y equals to r sin delta, where the dA is equals to r dr d delta. Okay, so we draw a graph, and we know that the radius is 4. So the r is in between 0 to 4, and for the delta is 0 to 2 pi. Now we have all of the information, so we plug it all into the formula and solve the integration. Substitute the curl of vector f in step 1. Dot the answer from step 2. Now we do the dot product, where the first component multiply each other same as the second, so we'll just left z, where z is equal to 5. Substitute the limitation of the integral, and also substitute the dA equals to r dr d delta, and just continue with the integration. And I skipped some steps from substituting the integral from 0 to 4, but we'll get the answer for the first integration as 4D. So continue with the second integration. And I also skipped the step on substituting the value, but overall we'll get the final answer as 80 pi.
Hi guys, so today I'll be explaining on exercise 2 of Stokes theorem. So actually the question asks for us to evaluate the line integral. So first, we know that the vector field f is equal to z squared, 3x and negative y cubed. And we also know that the closed curve C is of the circle is equal to x squared plus y squared equal to 1 in the xy plane. So we know that z is equal to 0. So now we need to find for the curl f, where we use the cross product calculation to find the answer. So after we compute everything inside the formula, we know that the curl f is equal to negative 3y squared, 2z and 3. And then after that, we know that n is equal to k, where right now we need to find for the dot product of curl f and n. So basically, n is equal to k equal to 0, 0, 1, where 0, 0, 1 is the constant. After that, we just compute everything inside this dot product, and we could find the final answer is equal to 0, 0, 3. How I got 0, 0, 3 is basically you just multiply the curl f with the k, and you got 0, 0, 3, and the final answer is 3. Basically, the final answer, how you get the final answer is by adding the 0 plus 0 and plus 3. And then after that comes to the last calculation, where we need to find the line integral. So we already know that the circle is x squared plus y squared equal to 1, and the boundaries we need to change from dA to r dr d theta. So basically, we already know that the radius is equal to 1, and the boundaries should be r is greater or equal to 0 and less or equal to 1, and the second boundaries, which is theta, is greater or equal to 0 and less or equal to 2 pi. And then after that, we just insert the boundaries into the integration of this line integral, and then the final answer should be equal to 3 pi.
Hi, have you ever wondered how rotating coil inside magnetic field can produce electricity? So to answer that, we actually can directly apply the Stokes theorem to help us understand how electric generator convert motion into electric power. So today, I and Sharvan will explaining how Stokes theorem work in electric generators. First of all, what is Stokes theorem? Okay, Stokes theorem relates to the circulation of a vector field around a closed loop to the curl of that field over the surface enclosed by the loop. So let's look into the equation form. This is the equation form. So that is the formula that apply in electrical generator of magnetism for Stokes theorem. Okay.
So hi guys, so the chosen real world problems is electric generator. So I'm Sharvin Rao myself. I'm going to explain about how the electric generator works conceptually. So let's visualize it. So imagine a coil of wire rotating inside a magnetic field produced by magnets. So as the coil rotates, the magnetic flux, the total magnetic field passing through the loops keeps alternating. So according to Faraday's law, this change in magnetic flux induces an current which is called electromotive force, which is technically an electric voltage. So the induced voltage drives the current through the wires, and that's how mechanical rotation turns into electrical energy. So that's the conceptual explanation. So the big question is where the Stokes theorem comes in. So the electric field circulates around the wire loop. So imagine there's a loop, and the electric field goes along the path of the loop. Okay. Then the magnetic field passes to the loop's surface. So Stokes theorem mathematically connects these two quantities, which is the circulation of induced electric field around the loop equals to the rate of change of magnetic flux through the surface. So instead of analyzing the field around the entire loop, Stokes theorem allows us to relate it to the magnetic change inside the loop, which simplifies a lot of things, which simplifies the whole physics concept behind the generator. So yeah, that's all from me. Thank you.
So to summarize this part, first of all, Stokes theorem connects circulation and also current. And then the second one, to conclude this part, it explains how a changing magnetic field generates a circulating electric field. And also the last one, this concept forms the magnetical foundation of Faraday's law, and therefore the working principle of electric generator. So thank you.